In lesson 1.1, we talked about finding x and y intercepts from a graph. Now we're going to review finding them algebraically. And to do that, to find our x-intercept, we make y equal to 0. And then to find the y-intercept, we set x equal to 0. And we've done this before, so here's just a quick review. So find the x and y intercepts. If we look at letter A, every problem is going to have two answers, right? It's going to have an x-intercept and a y-intercept. So we have to do this process twice for this one example. And so if I make the x value equal to 0, if I let x equal 0, I'm going to find my y-intercept. I'm going to find the opposite. So I do y equals 4 times 0 for x plus 1. And then if I solve that, I get y equals 0 plus 1, y equals 1. And then I want you to write your x and y intercepts as ordered pairs because we're given two values, right? We have to know we substituted 0 in for x, and then our answer was 1 for y. So our final answer as an ordered pair here would be 0 for x, 1 for y. So there's my y-intercept. And then if I do y equals 0, I can find my x-intercept. So I'd end up with 0 equals 4x plus 1. So here I have to subtract 1 over to solve. I get negative 1 equals 4x, divide by 4, and I get a fraction, and that is okay. Leave your answers as a fraction. Fractions are the most precise answers instead of decimals. So we get negative 1/4, and again, we need to write our final answer as an ordered pair because we have two values. We substituted in y as 0, and we got x equals negative 1/4. So in our ordered pair, I need to show that x is negative 1/4 and y is 0. So there are your x and y intercepts, finding them algebraically using zeros. So we'll do one more example. This would be a good spot to try it on your own, pause the video, and then check your answers. So for this one, if I make x equals 0, then I'll get my y-intercept, so 3 times 0 plus 2y equals 6. Anything times 0 is 0, so this is 2y equals 6, and I divide by 2. Pretty simple, y equals 3. Ordered pair, x I made 0, y solved to get 3. And same idea, if I make y equal to 0 to find my x-intercept, I get 3x plus 2 times 0 this time equals 6. Again, 0 is 0, so I get 3x equals 6, divide by 3 this time, x equals 2. So my ordered pair, x we solved to get 2, and the y value we substituted in was 0. So there are your x and y intercepts, a review of solving algebraically. Leading then into an application for this, you have the number y in millions of female participants in high school athletic programs in the United States from 2000 through 2010 can be approximated by the linear model here. And that linear model is the equation. So a linear model, let's just make a note. This is an equation. Okay, so along with that equation, we have these boundaries. This is our domain. And what that tells us is we start at the year 2000, so they're using a 0 for 2000, and then it's going through 2010, so they're using the number 10 instead of 2010. We can kind of simplify it down to 0 to 10. And then it's telling us that t equals 0 represents the year 2000. So that's good to know to confirm what we just talked about. So a couple different representations. We can use algebra to find the y-intercept. So if we substitute in, because remember to find the y-intercept, we make x equals 0. And the work is done here for us. This is just going through the example in the book. If we substitute in t, because t is our x value, we're using t for time instead of x. So we substitute in 0 there. We're just left with this 2.70. Okay, so what does that mean? It means that that 0 was the year 2000. Then our answer, which, if we go back, what are we representing? We're representing Y, which is millions of female participants in high school athletic programs. So this is 2.70 million female high school athletes. So That's what that value is finding. So whenever you're given a word problem and you're substituting values in, it's really important to know, what are you finding? What are you solving for? What are you substituting in? What does it represent? So here it gives that explanation in words. Same thing that we just talked about. And we have this graph of a model to go off of. There's what the graph would look like. Now, the part B, use the model to predict the year in which there will be 2 million. Okay, so now we want to predict the 3.42 million. I didn't have my screen showing. 3.42 million. So this time, if they're giving me the female participants, that's our Y value. So that's why it says let Y equal 3.42, solve for time, because we want to predict the year. So if we do that, we substitute in that 3.42, subtract that 2.70 over, and then divide. We're solving for t, so we divide by 0.045. And your t value would be 16. And remember, t is time, so this is the year 2016. So what this means is that in the year 2016, we can predict, using the model, that there will be 3.42 million female participants in high school. So we can use our models to predict, and we can use our models to find a starting point. All right, that concludes our notes for this lesson. So here's your assignment, 1 through 6, all, and then 7 through 51, just the odds there. And then please make sure you're checking your answers with the answer key posted.